Is we know that the vapor pressure of solution decreases when a non-volatile solute is added to a volatile solute. There are many properties of solutions which are connected with the decrease of a vapor pressure. They are relative lowering of vapor pressure of the solvent, depression of freezing point, elevation of boiling point, osmotic pressure. Okay, these are simply called as colligative properties. The properties of ideal solution, which depends only on the number of solute particles in the solution, is called as colligative properties. Colligative properties are the properties of ideal solutions. Ideal solutions, what are ideal solutions? Ideal solutions are the solutions which obeys Raoult's law, which only follows Raoult's law. These colligative properties mainly depends on the number of the solute particles. How many solute particles are present in the solution. These type of properties are called as colligative properties. Let us discuss these properties one by one. The important colligative properties are relative lowering of vapor pressure, elevation of boiling point, depression of freezing point, osmotic pressure. These are the four important colligative properties. We'll understand each of them step by step. Lowering of vapor pressure. The first property of colligative property. This property was mainly explained through the help of Raoult's law. Raoult established that the lowering of vapor pressure mainly depends only on the concentration of solute particles, and this is independent of their identity. Okay, the vapor pressure of liquid decreases when a non-volatile solute is dissolved in it, and the decrease in pressure is proportional to the amount of solute dissolved. We know that colligative properties are the properties which depend only on the number of solute particles. Same here, the vapor pressure of liquid. We know that the vapor pressure of liquid decreases when you add a non-volatile solute to it, and also vapor pressure of liquid increases with the increase in a temperature. Let us understand how the relative lowering of vapor pressure takes place through the derivation. According to Raoult's law, we have already learnt the Raoult's law in detail. P1 is equal to x1 P1 naught is the equation formed during the Raoult's law. P1 is the partial pressure of component 1, x1 is the mole fraction of component 1, P1 naught is the pure component of 1. The reduction in the vapor pressure of solvent delta P1 is given by, what is reduction? Reduction means here difference. Okay, the difference in the vapor pressure of solvent is denoted by delta P1. Delta P1 is equal to P1 naught minus P1, means partial vapor pressure of pure component minus partial vapor pressure of a component 1. Okay, delta P1 is equal to P1 naught minus x1 P1 naught. This is because we know the formula of Raoult's law, that is P1 is equal to x1 P1 naught. Here P1 is equal to x1 P1 naught. So P1 naught is minus x1 P1 naught. P1 naught here x1 P1 naught. When you take common here, you get this. When you take P1 naught common, then you get P1 naught minus 1 P1 naught 1 minus x1. This is the equation 2. We know that sum of the mole fraction is equal to 1. That is x1 plus x2 is equal to 1. x1 plus x2 is equal to 1. So x2 is equal to 1 minus x1. x2 is equal to 1 minus x1. Okay, here we have got 1 minus x1. Instead of 1 minus x1, we can put x2. That is delta P1 is equal to P1 naught x2. In a solution containing several non-volatile solutes, the lowering of the vapor pressure depends on the sum of the mole fraction of different solutes. Delta, when you take x2, what is x2 is equal to delta P1 by P1 naught. x2 is equal to delta P1 by P1 naught. What is x2? X2 is equal to n2 by n2 plus n1. This is the formula which we have already learnt in our earlier classes. X2 is equal to number of moles of 2 divided by number of moles of 2 plus number of moles of 1. That is n2 by n2 plus n1. Equation formed is delta P1 by P1 naught is equal to x2. Here delta P1 can be reducted as P1 naught minus P1. P1 naught minus P1 divided by P1 naught is equal to x2 by n2 by n1 plus n2. Here n2 is very small than n1. So this n2 can be neglected, because if this is small, this small value cannot be considered. It is useless. For dilute solutions, n2 is very less than n1. Hence, neglecting n2 in the denominator we have. When we neglect this, what we get? Let us see. P1 naught minus P1 divided by P1 naught is equal to n2 n2 by n1 is equal to this. Okay, here W1 and W2 are the masses, M1 and M2 are the molar mass of the solute and solvent respectively. Okay, when you rotate it, when you take this W2 by M2 into M1, take up M1 by W1, you get this equation. Here are W1 and W2 are the masses, and M1 and M2 are the molar masses of the solvent and solute respectively. Thus, we have got the relative lowering of vapor pressure.